Welcome folks. What I have for you today is another oxygen testing video. On my first one I used a digital low meter, and what I have in the background here is a nice large analog meter. It's got the kind of waving pointy needle that'll move and it kind of waves at you, if you will. So what I'm going to do is I'm going to use the same oxygen sensor. That way we can sort of compare notes with the other video, the yellow multimeter I used. And I'll use, this, like I say, the same oxygen sensor so that there's no difference, hopefully, depending on how accurate this meter actually is compared to the digital one. So we'll fire this propane torch up and we'll just have a look at what this indicator needle does here. Maybe I should point this out too in case you're not familiar with the scales. We'll be just using the low volt scale today. I'll just basically show you. It's on the 0 right now, meaning nothing's passing through this thing. It's sitting in the 0 position. There's 1 volt on this scale. We're using the low volt scale. So you see this, you just basically put a decimal in front of these numbers there. Before the 5 would be decimal 5 or half a volt. That would be 1 full volt. And 1.5, 2, 2.5, and 3. Probably with an oxygen sensor being a narrowband one like I've got in this video that I'm going to show you, it should be give or take around half a volt once the propane torch warms it up to that magic 600 degrees Fahrenheit temperature. So we'll be looking in this area here if it's working correctly, and then I'll once I get it heated up, we'll see where it lands on the meter's needle there, and then I'll take it out of the flame quickly and then put it back in the flame, and we'll watch the response of this oxygen sensor. And if it's doing its thing, then the indicator needle should fall to 0 or thereabouts when you take it out of the flame. That's once you got it heated up. And then back into the flame once it hits 0, and we'll go back and forth a few times once it gets cooking. And the reason I'm doing so much talking now is you might not be able to hear me once I fire up this propane torch here. So here we go. Not the loudest flame today, but anyways, what I've got here is I've got a vise off to the side here. Help steady up the video. And gotta wait a few minutes. A lot of the newer oxygen sensors, they have a little heater built inside them to help get them up to operating temperature. Otherwise, with a cold engine, it takes quite a while for the exhaust to heat this sensing tip of the oxygen sensor up. So watch that indicator needle in behind there. And once this thing gets cooked up to its magic 600 degrees Fahrenheit or better, we should be able to see some response on that indicator needle on the meter, provided I hooked everything up right, that is. I can hold it a bit steadier. I've got I don't know if I'd mentioned just a minute ago, I got a vise clamped onto the workbench here, and I've got a piece of 1/2 inch round steel stock here. And my little vise grips here are kind of holding the body of the oxygen sensor along with a ground wire. Now we're starting to see something happening here. I saw something move there. We just got to get the flame in just the right place. This it's not like the exhaust, the hot exhaust coming through the exhaust pipe from the engine where it surrounds this whole thing. I've only got this tiny little flame here, and I'm trying to concentrate it in the right area so it'll get inside the louvers on this. I believe it's a protective housing on here, and the actual sensing element is inside there where you can't see it. There, we're seeing some kind of activity there. I get this flame just right in the right position and the right distance from the pretty sure once it gets hot enough it should respond okay. I can see some movement now. Do it just right. Move things around a little bit and see if we can find that magic distance, and there we go. Get this thing pointed in the right direction. Just move it around until it likes. There we go. Sounds more like where it should be right about now. Somewhere around the 0.5 volt range, or 1/2 of a volt DC. And you can see there with the needle there, it's right around the 5 mark, which is decimal 5 actually, because we're on the low volts range, not on the high volt range on this meter. It's a little bit over now. I guess you could say, I don't know, from the angle you're seeing it with the camera where it's mounted, it's probably somewhere between 0.5 and 0.6 volts, which is fairly common reading with a narrowband oxygen sensor that is functioning, at least acceptably. Yeah, it's almost going up to a 0.6. Like I say, don't forget to put the decimal in front of those numbers on that scale I was telling you about, because we're in the low volts range. Okay, now that it's there and stabilized, we're almost 0.6 volts. Got to remember, this isn't gasoline or gasoline with ethanol mixed in with it. This is a propane flame, and it's got a slightly different, you might say, air-fuel ratio. But this meter, I don't know how accurate it is compared to the digital one. So now you see that it's stabilized there. I'm going to remove it from the flame, and hopefully it'll go back to 0, and then we'll put it back in the flame quickly and see if it comes up. And that'll tell us whether or not the oxygen sensor has half a chance of operating properly in the vehicle if it's ever installed again. So here we go, we'll take it out of the flame. It drops right. Wow, this meter's doing some funny things. I don't know if that's... should only go back to 0 as far as I can tell, but maybe there's something going on with this sensor, I don't know. So back in the flame, and you can see there it's back up in the same old neighborhood where it used to be, now almost 0.6. I was hoping to see some what they call cross counts. I believe if I was kind of thinking we'd see some fluctuation going high and low on this indicator needle on this meter. I believe you might even have to have an oscilloscope in order to track this thing, and if it's doing any cross counting at all. No expert on an oscilloscope, so all I can show you is what I got on my analog meter. I'll take it out of the flame again. It drops down. See, I don't know how good this meter is, but it should come back to 0 once it stabilizes. Go back into the flame. Providing it gets hot enough, it should go back to where it originally was. I'd almost say that this oxygen sensor might even work okay in a vehicle. The vehicle this one came out of, it only had a single oxygen sensor before the catalytic converter anyway. So that's about it for what I got to show you with this. Take it out of the flame one more time. Turn things off here. And so there you have it, folks. Basically, what it would look like is if you're using a analog meter like I've got here. This one here is quite a large one. It's served me quite well over the years. Got various push buttons on it for all different kinds of tests. Mind you, it's analog. It's probably not as accurate as a digital readout meter like I have these days, but I like having both, actually. It's more fun watching a needle than it is a bunch of stationary numbers that are just moving and not giving you much activity or anything, whereas you get to watch this indicator needle. That's kind of fun. So that's about all I got for you for today with this oxygen sensor test with this analog type meter. So I hope you enjoyed it, and if you see anything that you want to comment on under this video, by all means, I'll do what I can to help you out, or might even teach me a few things or two if some of the experts get on there and leave a comment or some information that we could all use. Okay, there you have it. Have yourself a good day, and till next time, take care, and bye for now.